just in case folks want to revisit it in the future.
Okay. Thank you, Jordan. Thank you, everybody. Can you see my screen?
Yeah.
Okay. Well, my name is Steve Fugate. I work for Vermont Center for Geographic Information as the LiDAR program manager. And today I'm going to speak to you guys about what it's like hosting cloud-optimized geotiffs. I'll just start with a disclaimer that I'm not an expert in this space. But nonetheless, we've had good experiences kind of working in the sandbox as far as developing our use of COGS, and we're getting good feedback from our user community. So I'm happy to share some lessons learned with the group. Today, we're going to talk about some of what it's like hosting raster data here in Vermont and some of the challenges that we have meeting user needs and how COGS can help to meet those challenges. Then we're going to get into some details about the creation of COGS using GDAL utilities and some considerations, and where we've chosen to put them, which is in an AWS S3 bucket. And then the last bullet, no, second to last bullet, it's the most exciting. It's how to utilize COGS. So we've got some the potential for a live demo, although those never really go very well. So we'll see. And finally, we'll wrap it up with other cloud optimized formats. Okay, so big raster data, man, it gets bigger, bigger, and bigger. And I think USGS 3DEP it speaks to that in terms of they've gone from an eight-year cycle to a 5-year cycle. QL1 is much larger than QL2. And then there's other considerations like hydro and forest and topobathy dens. And so the data just keeps piling up. And, NAPE imagery is very similar. They've gone from a 5-year cycle to a 2 to 3-year cycle, and their resolution has increased as well. And along with that, state ortho programs are on a similar kind of path. And all of this is resulting in a huge amount of information. Vermont is a relatively small state, less than 10,000 square miles. But nonetheless, we host about 25 to 30 terabytes of imagery and data. And with the increased frequency and resolution that we just mentioned, this is expected to double in the next 2 to 3 years. So that presents challenges. All kind of wrapped around this expectation that we're trying to meet multiple use cases when we're serving this information. So what do users want? Based on surveys and just our experience in this realm, they want to download and stream data. Now, when it comes to downloads, most kind of want small files of a customized extent if possible. Lossless versus lossy, we can discuss some of those differences in later slides. But when it comes to streaming, again, most want fast performance streaming. Usually you get that from a cached image service. But others want access to the pixel data that comes through a dynamic image service. So our old approach for this information was to serve downloads. We've got Imagine and JPEG 2000s and GeoTIFFs by tile served up on Google Drive, as well as like bundled zips of the whole acquisition or different extents. Those downloads can be gigantic though. When it comes to streaming, we've got the tile cache. We use ArcGIS image server and the OGC compliant like WMTS and WMS for dynamic. And that's kind of how we've been meeting these user needs. There's challenges with that though. This is our tile index grid. And this is a small state. So we've got thousands of tiles that are available for download. Users will inevitably be working along the margins of these tiles. And so they'll have to download more than one or several, depending on their area of interest. Well, Google Drive didn't really handle the bulk downloads very well. And as I mentioned, those large mosaic downloads are gigantic. I mean, they're hundreds of gigabytes. It'll take hours to download. In terms of streaming, you know, we have the cache and the dynamic. Those are our options. Cache services are really performant, but they're what I call dumb maps. There's no information there. They render quickly. They're snappy, but you don't have any access to pixel data. And from what we can tell, the most recent release doesn't. There's a bug with the dynamic caching feature, which we did utilize, because for those of you that have cached data, when you zoom in, that gets exponentially large, and anything beyond like 1 to 1200 scale gets really big. So we've been relying on dynamic caching for that, which is apparently there's a bug. So that's no longer an option for our cache services. Dynamic services are a little more complicated, and they involve a lot of server load. Those requests, as they come in, they're getting full pixel data access. It requires a little more in terms of Esri licensing costs. So cloud optimized geotiffs, they do help to address these issues. Dun, 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 dun. They have the same functionality as geotiffs, which is great. It means they're backwards compatible. If anything you have that can read a geotiff can read a cloud optimized geotiff. They're relatively easy to create using simple GDAL tools. There's 2 utilities that it takes, depending on if you're doing tiles or mosaics. We'll get into this in later slides, but it's surprisingly simple and complicated at the same time. What makes cogs work is that they're optimized. So optimization means that there's tiles and overviews embedded into the geotiff. And this results in faster access to the data, and depending on what level of zoom you're viewing the information at, it'll render because it's got downsampled overviews, and that's what kind of makes it snappy and responsive as you zoom and pan. And they're streamable. It leverages the HTTP get range request. So depending on your extent and your level of zoom, it's just grabbing the data that it needs to grab. And if you're zoomed way out, then it's grabbing a tiled overview. So it doesn't require this whole bag to come along for the ride. So combined with different compression, it creates a really high performance, streamable, downloadable raster with full pixel access, all in one. And this is just a little illustration of how that might look. So now we're going to get into, I'll try to be quick through these slides because there is a lot going on here, but this is just an example of the simple bash script that's used to create a cog. Now this is a tiled cog. You set your environmental variables to point to the GDAL library and the projection library, and then your input path and your output path. And it will run through every file. In this case, every file with an img suffix, it will convert it to a TIFF and then use the GDAL translate utility and some creation options here to compress it and create the cog. So this one is for tiles. If you wanted to do a mosaic cog, it is an initial step you need to take where you have to create a virtual raster table, which is very similar to a mosaic dataset. And here you can see I've got input folders that correspond to the different acquisitions that we've used or that we've had over time, 2013 through 2017. This will loop through every single one of those files in those folders, and it puts them into that virtual raster table. And that uses the GDAL build VRT utility. Once you've run the build VRT utility, then you use that output for the next input of the GDAL translate utility. Again, and these CO, that's a creation option. So this has to do with compression and different settings relevant to the compression. Certain considerations, compression type is definitely, you want to think about that. For LiDAR, from what I understand, the LERC, limited air raster compression, is a really good compression for elevation data. It's called controlled lossy, so it can be lossless or it can be lossy depending on that max Z error setting. A max Z error of 0 is essentially lossless. Imagery, for lossy, for if somebody wants to just use it as a base map, JPEG quality 75 seems pretty good. If folks wanted to use it for image classification and they need that unadulterated pixel data, access to that data, you might want to use a lossless compression. But it should be noted that when you cog a geotiff, if you have a lossless compression, it will get bigger because it has those tiles and overviews embedded into it. If you choose a lossy compression, it will be reduced in size and still have those tiles and overviews built in. So again, it depends on the user needs and trying to meet those specific use cases. In terms of the mosaic cogs that require the VRT, every input tile needs to be in the same CRS. So I don't know if you guys caught this right here, the NAD 83 2011. This was before my time here, but the 2013 and 2015, they were in different coordinate systems. So they needed to be reprojected in order for the VRT to be functional. Something else that's unique to Vermont, we're a small state. From what I understand, mosaic cogs at a statewide level isn't something that people are utilizing, but again, Vermont's a small state, so we can get away with things that maybe other states can't. If you did want to go the mosaic cog route, you have to use a creation option of setting of big TIFF equals yes. So again, pretty simple. And this slide was kind of added last minute just to communicate to the group that this is a relatively new space. And I mentioned earlier, I'm not an expert here, but there's areas of research that are happening now to understand different implications of statewide mosaic and if that's feasible for your state. But I've shared the slide deck with Jordan, and he can share this with the group as well, and all these links can point you to some additional resources. So we decided to put our cogs in an S3 bucket in AWS, and we've leveraged the Open Data Sponsorship Program because mainly it includes free storage and egress costs for publicly available cloud optimized data sets. So it has to be cloud optimized as part of their criteria. And if you guys are going to apply to this program, you'll see that you need to check some boxes. And there's some technical requirements in terms of configuration of the command line interface and your user profile, and it gets into some systems administration space here that I don't really want to speak to because I'm not terribly familiar with it, but we ran into a little bit of challenges because I work on multiple machines and they're all set up differently with state domains. And so be prepared for some hurdles there when you're configuring your interface, your CLI or AWS. But the goal here was to essentially increase access to the data, democratize the data in a space where we could leverage these cloud resources, learn new techniques, formats, and tools. And in doing so, hopefully encourage everybody that is accessing these shared data sets. AWS tools that I'm familiar with, the browser-based, one is fairly user-friendly and intuitive, but it's limiting. You can only move data sets and rename them up to a certain size. And for most of our cog mosaics, we exceeded the 5 gigabyte limit. So I tended to rely on some batch processes for instance, for moving an object, a cogs mosaic object from our dev bucket to prod bucket. We fooled around with our naming conventions because initially we thought of AWS as a repository, but now it's kind of becoming a front counter in a way where, and we can talk about this on the next slides, where you connect to the bucket through Pro or QGIS. And so you want the naming conventions to be organized in a way that's intuitive for your user. And that's not necessarily the same naming convention that we use as data managers. Sometimes they get really cryptic. But beyond the using batch processes to move and rename large objects above 5 gigabytes, the CLI S3 tools, they're the most capable and the most advanced. I didn't really get into that too much. It was a rabbit hole I didn't choose to go down. I relied on FileZilla Pro to upload data to the bucket. You need the Pro version to establish a cloud storage connection. But that was the easiest and quickest way to get data into that cloud storage space. And this illustration on the right here just kind of goes to show that there's ongoing work to improve these tools. Okay, now we get into the kind of the meat of this presentation, which is how are we utilizing cogs? Most of our users are Pro or QGIS. I know we have a lot of ArcMap users still, but from what I understand, ArcMap doesn't readily connect to a cloud storage bucket. I believe there's ways to do it, but we're trying to encourage users to finally make the move to Pro. So we're trying not to get into ArcMap support in terms of cogs at this point. But we have created a kind of webified how-to document that goes into detail on how to connect to a bucket in Pro and how to connect to an object in QGIS. And in a sense, the user, once they establish that connection and it's in their table of contents in their document, they can zoom to an area of interest and they can download that for work locally. So it kind of doubles as a clip and zip. We've had our clip and zip has been kind of fickle. So we've had to come up with alternatives, and this has been one of them. QGIS is free. So, it can be challenging to ask a user to engage in something new, like learning QGIS, but it is a viable alternative. It works, it's functional. And so that's what we've tried to do, is support our user base by developing how-to documents for them to connect to the bucket, stream these data sets, and then ultimately download them for their area of interest. Now, our director at VCGI, he's curious with things like AI and open source solutions, and he's been developing really cool apps. This one here it's called the Topo Change Mapper. And what it does is it references our QL2 cog, our cog mosaic from 2013 and 2017 with our cog mosaic of the 2023. And it performs a topographic differencing, which is essentially just subtracting one DEM from the other. This is a large landslide that took place between then and now, and this demonstrates that topo change concept of understanding where you've lost and where you've gained ground. Another app that he spun up was a elevation profile, or Find My Elevation app. On the left here, you've got a long profile that spans the the spine of the Green Mountains. And on the right, you've got a short one that goes over the Capitol building, and you can notice the toggled on DSM, which will give you the difference between the ground elevation and the top of objects. And if we have time or interest, I'm happy to demo these. And some other cloud native formats that are worth consideration, at least for vector and point cloud data, GeoParquets seem to be rising to the top. And I believe the most recent pro release, 10.5, has functionality with GeoParquets. So once you connect to the cloud storage container, if you have a GeoParquet in that space, you could drag it right into your table of contents and stream it just like you would the cloud optimized GeoTIFF. Flat GeoBuff is another option. I've worked with that one in QGIS, and it is streamable. And then, of course, cloud optimized point clouds. And that pretty much concludes the presentation. And yeah, thank you guys. I appreciate you guys giving me the space to talk about this, and I'm happy to take questions.
Awesome. Thank you, Steve. Anyone have questions for Steve? I guess I see Jennifer dropped a question in the chat here. She's asking, does the AWS Open Data Sponsorship Program report back to your storage and egress usage statistics?
I would think they have that capability, although I'm not privy to any of that information. It's a good question. Is there an export limit for the COG?
There is logging that you can turn on, and we have it turned on for Indiana, but we haven't done anything with it. So there is a lot of potential.
For the usage statistics.
Okay.
Yeah, I think Kent from Kentucky has been able to produce some metrics on that. But I'd
be interested to know for sure.
Yeah, because I think right now there's just a lot of talk about, or a lot of sort of fear around the costs, and so there's decisions being made possibly to prevent high costs because of a high storage need for COGs. COGs are so big. When the performance of the COG is designed so that it is optimized for those sorts of things. So I'm just wondering if anyone's ever done any comparisons, like you've got a cloud raster format, Esri proprietary data set in the same bucket as a COG, and is there really a difference in speed, performance, or cost? Like why use one and not the other? I would assume the reasoning usually is cost, but if cloud raster formats are not accessible in QGIS, then that's a reason not to do it.
My colleague did some work on evaluating performances of different COGs in AWS and Azure and Mosaic data sets and dynamic image services. And the differences were nominal. But I think COGs, and I can provide some of he created a report, and I can share that with the group as well. But if I feel like the rub with COGs is that it's an opportunity to potentially go serverless as an alternative to the dynamic image service where you need pixel access to data. But I don't believe it's mature enough in its browser support. It's getting there. But that's the main hurdle now, is that COGs they can't check every box that a dynamic image service does, but it does. It's got the potential to maybe replace them at some point.
Yeah. Hey, Steve, we've tinkered with here in Indiana. I created an MRF of the 2016 to 2020 DM from our LiDAR collection. And it's a 2.5 foot native product. So I just kept that native resolution. It's an MRF, which is, AKA COD, cloud optimized, file format. It's Esri's format. But I saved it in the AWS bucket, and with the ACS connection, ACS Esri file connection, users are now able to do flood analysis, hydrologic modeling, whereas that, like the dynamic service, that's why years ago I thought, oh, the dynamic is the end all, and then what do you know? There's limitations on the pixel width of your project area on the dynamic service. So that was a little bit of a learning disappointment.
Okay,
and,
no, that's interesting. Esri has a COG alternative. I didn't realize that, and it makes sense that because the dynamic image service for analysis, that's a huge request depending on the size. That can really bog down a server.
And it wasn't a terribly large file. It was, for considering it was a 2.5 foot DM. Obviously a 3-inch ortho imagery, that would be a different story. But yeah, and then I've got a couple questions. I really appreciate you having this presentation. But one was, you were mentioning the file size, and the file size actually doesn't balloon any. I mean, if your geotip already has overviews embedded in it, there is. I don't think there's really there's a negligible change in the geotip versus the COG. And then, we also went through, this would be maybe for the group, to consider the Lambda event function in AWS, because it was a really powerful way to convert, and I still prefer that to doing the conversion on-prem and then uploading the COGs. But I think that, and it's extremely cheap. When we did, 40 terabytes for maybe $100.
Wow. Yeah, I've heard of the Lambda function.
Yeah.
I can't recall why we chose to go with the GDAL other than open.
Yeah.
Well,
I think it's easier. I mean, there's less.
Right.
Yeah. It took a lot of exploration, and plus we were starved for on-prem storage, so we didn't have any on-prem storage. So
right. And that's really good to know. Alternative methods, like because the Lambda function was one that was brought up, and we didn't explore that, but it's good to know others have, and that was a fruitful avenue.
I would highly recommend users giving that a try. It does come with a little bit of upfront technology. Once it's in place, though, it works really well. And I can commiserate with your AWS bucket, how you organize your files, and same with us. I try to be systematic, but you're always kind of reacting to new requests and ideas of what to place in your bucket. And now, with the S3 browser, everybody has access to seeing, how Sean thinks, which is not really what I'd like to reveal.
Yeah, for better or worse.
Yeah, but yeah, and the one question I have for the group is the file size, because I keep getting hit from Esri, who's, we're using Esri's AID ArcGIS Online image dedicated, image server. So for the DM, for the ortho imagery, we're using those that dynamic imagery service. And one of the problems is, we keep on reducing the file dimensions. I mean, at 3 inch, we're down to 1250 feet by 1250 feet. So that's just a lot of files then to reference within the Mosaic data set. And even though the images are optimized, it's still a lot of calls to, find the files that are necessary to render within the area of interest. And I don't know, are other states, what file sizes do you guys use? Is it 5,000 by 5,000, regardless of pixel size, or what works? Because
Yeah, that's a good question. I don't have an answer for that one, other than it does seem like it would be directly related to resolution.
yeah.
Hi, this is Jennifer from Minnesota. I don't know if this answers the question directly, but in Minnesota, we have a nested tiling index that we use that has a naming convention so that we can go down to the 500 meter by 500 meter size tiles and then roll those up and locate them within a 10K by 10K and then roll it up further than that too. It just helps with this folder structuring. And that's one huge lift that I think is still underway on trying to set up the folders in a way that makes sense for that, especially when you have tiles and you have mosaics. And I don't know. So I'm not sure if that helps, but the vector tiling scheme in theory was to at least help with the naming conventions and locate where some of those raster products might be in space based on their name.
Yeah, so we use the lower left coordinate pair for our file names, but yeah.
This seems like it's, I'll just bring up the stack because it seems like that's a solution that Kentucky has implemented. And from what I understand, I don't want to say it's the holy grail, but having cogged tiles in a stack seems to offer a lot of functionality and user access and flexibility. And it improves administrative management of these data sets too. But we're just still dabbling and learning about the stack. So I can't really speak much about it.
Yeah, here in Indiana, in the state, we haven't done it, but the Purdue University, with Jin Ha, he has created a stack, I want to say stack catalog, but I'm repeating the acronym, but of various data sets, some of the Indiana LiDAR and Indiana imagery and even the NAPE and other products. But Esri's version, you have to be a little careful because some previous versions, they start working with allowing you to work with the stack, but then don't always follow through. There's some glitches on earlier versions of Pro, but the most recent, I think, is a pretty solid platform. And it does, like you say, allow users to interact with GP tools with those products. So you don't have to download the files anymore.
Thank you, everyone. I want to make sure we're hitting Abby's question in the chat here. I know there's been a lot of discussion around interoperability with ARC and the difference between that and QGIS. She asked if a mosaic cog can be published through ARC image server.
Yeah, I believe my colleague did that. So I want to like tentatively say yes. But I'm happy to follow up with you if you'd like.
Yeah, thanks, Steve. This has been a really great presentation, so I really appreciate that. We're just starting to look into COGS and kind of developing that as we're moving towards developing a new LiDAR portal. And our agency definitely uses ARC image server and whatnot, but trying to kind of leverage some of these ideas to make things a little bit more efficient. So yeah, I might follow up with you. I really appreciate the presentation.
Thank you, Jennifer. Yeah, this is the goal, right? Is figuring out how we can disseminate this. I will be posting this recording along with the associated deck to the knowledge base. So if anyone wants to go and review that anytime, that would be the place to do so. How to get it into a cohesive catalog of do's and don'ts and guidance that is actually consumable is a work in progress. So open to feedback there if you have any, Jennifer. Anyone else have any questions for Steve or for the group on cloud optimized geotiffs?
This was really great. Thank you so much.
Oh, I'm
Just wanna
glad
say
you got
thanks,
that.
Steve.
Yeah, my pleasure.
Right on. Well, we're well past the top of the hour, and I really appreciate everyone's participation today. I think we covered a lot of ground. Looking forward to seeing those FY26 DCA submissions come through, and hopefully seeing you guys at the annual conference. Keep an eye out for those interest group meetings coming up later this month and next month. And thanks everyone for a really engaging state team meeting today.
Thanks, Jordan.
Thanks, Jordan. Thanks, everybody.
Thanks for
Thank you
hosting.
all.
Thank you. Bye-bye.